we want to graph this piecewise function. There are two functions here, 3x plus 4 when x is less than -2, and 1 plus 1/2 x is when x is more than or equal to -2. Now, both of them are linear, so we just have to graph the straight line and make sure that we're only connecting the line according to the domain given here. Okay, so let's do that. So first thing, we would like to graph the xy plane and then specify the domain for each of them. So I'm going to draw an xy plane, right? xy, or x and f of x. And we noted that -2, this is the point that we are given here. So let's just call this -1, and -2 is around here. Okay. So you can make a divider just so we can keep track which one is which one. On the left side, less than -2, right? Then we have this function 3x plus 4. Okay. So all you have to do now is you just have to find 2 points on the left side of -2 so that we can connect the point together, right? Well, the first point we can find is actually the endpoint as exactly as -2. What happened when we are at this location as -2? So when x is -2, I'm going to take that and then plug this in. Then I get 3 times -2 plus 4. This is -6 plus 4, which is -2, right? So when we are at exactly -2, then the value for the f should be -2 for y. So -1, -2. So that would be this point. Now I'm using the open circle because we do not have the equality here. It's only less than or equal to -2. That means we do not include the endpoint. We do not have the value when x is equal exactly to -2. And therefore we use the open circle for this endpoint. And then I need to find another point on the left side of -2 because the domain is less than -2. So let's find another point. Let's just say -4. Right? What happened when x is -4? Again, we are using the same function. This one, f of -4. Then I'm replacing the x with -4, and I get 3 times -4 is -12 plus 4, and that should be -8. So when I'm at -4, I need to go down to 8. So this is -3, -4, -5. I need 3 more. -6, 7, and 8. So it should be this point right here. Right? This is -4 and -8. And then we can connect the 2 dots together. Something like this. Okay? Now we stop right here because we do not want to go over -2. That would be the second function down here, right? The second part of this function. So we only hit to this point, which is the border line before we enter the second region. So, but then the line can keep going down forever, right? Because we can go all the way to the left side. As long as we are on the left side of -2, we can go all the way to the left side, and the line just keep going down, down, and down. So we can make an arrow like that, indicating that the line will keep going forever down here, right? But then it will stop right here. Now, for the second part of this problem, we are given this function here. So again, we have to find 2 points, and this time we see that we are actually including the -2 because we have the equality here. So I'm going to take -2 plug in here, and then I get 1 plus 1/2 and minus 2, right? And it will give me minus 1 for the second part here, and 1 minus 1, it is 0. Okay, it is 0. So when x is equal minus 2, the y value is 0. And this time we have the closed dot because we are including the value of the endpoint. When you are at the location x equal minus 2, you actually have the y value of 0. And we are including this value, so we use a solid, the closed circle, instead of the open circle. And then we only have one point. I need another point to the right side, right? It's bigger than, mean to the right side of minus 2. So we can pick another point. Let's say I want to pick what happened when I'm at 0, right? Then when x is equal to 0, I will find f of 0 using this function here, 1 plus 1/2, and then I replace the x with 0. It will cancel the second term, then I will get 1. That means when I'm at 0 for x, then my y value is 1, which is this location. And then now I have 2 points. I can connect them, and then the line will just keep going to the right side with the same slope like that to the right side. And again, as long as we are on the right side of minus 2, then we are okay. So I can go from here, 0, 1, 2, 3, 4, 5, whatever, right, to the right side. And the line will have the same slope of 1/2, and it will keep going up, up forever to the right side. And we can just make an arrow like that, indicating that the line will go this way for the second part, and then the red line will go down this way for the first part. And this is a complete graph of this piecewise function.